Hello, welcome to Slice of Physics. This time I'm going to talk about arrow maps, which are a different kind of map that will also be useful in this course. So just as a number map is a map where we draw a number at each point in space, likewise an arrow map is just a map where we draw an arrow at each point in space. So let's consider an example. Suppose there's a river and the river gets wider as it flows, and then it gets narrower. So how fast will the river flow at different points? Well, over here, where it's starting, the river has a much narrower width, and the river has to flow much faster in order to put a certain volume of water through. So the river will be fast here, and here where it widens out into a little mini lake, it will be slow, and back here it will be fast again. If you're familiar with rivers, you might be familiar with this fact that when the river widens out, it will start to get really slow. So I can draw an arrow on this map that shows the direction of the flow of the water. So here the water is flowing this way, and here it's flowing this way, and it's flowing like this. So I'm drawing lines that show how it's flowing. But I should also draw the length of that line to indicate how fast it's going. So where it's going fast, I should draw a long arrow and then a somewhat shorter arrow, and arrow. And towards the center of the lake, it's really going slow. So this is an arrow map that shows how fast the river is going at each point, and also which direction it's going. So with any arrow map, the arrows have a magnitude, which is their length, and in this case it equals the speed of the water, but in other cases it might mean something else. And they also have a direction. And in this case the direction of the arrow is the direction that the water is flowing in this river. Okay, now let's come up with a different kind of arrow map. Okay, suppose I have a house, and this is my picture of a house from above, and suppose it's a very windy day, and the wind is coming up from the north. So the wind is coming in, and I could draw an arrow map showing how fast it's going. Just like I could show how fast the river was going, I could show an arrow map showing how fast the wind is going. But I'm not going to show that. I'm going to show something else. So this is going to be an arrow map of force. An arrow map of the force of the wind on the house. So let's say that over on the right side of the house, the wind is especially strong. So the force of the wind on the house is like this. And over here, it's not as strong. Right? So strong force over on this side and a less strong force over on that side. And maybe over here there's a little bit of force, not as much. And maybe on the other side of the house there's no force because the wind isn't coming from that direction. So actually what I'm drawing here is described as pressure. It's the pressure of the wind. But you can think about it either way. The wind is certainly causing a pressure and it's causing a force. And these arrows show how strong the wind is on that part of the house. The main point here is just that I can draw an arrow map which shows the forces exerted by the wind on the house. Okay, let's do one more. Let's suppose that I have a big old plus charge at the center of this picture, and let's suppose that there is a lot of little plus charges around, right? Different size plus charges. There's a big one over here and a little one over here, like that, right? So now I can draw a map that shows the force of the plus charge on the other plus charges. So it's repelled, right? So there's a force going away, 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 away. These are pushed away. Okay. So here's the interesting point. We can also draw a map that shows the force that would be there if there were a charge there. So if there were a charge here, there would be a force pushing it in that direction. If there were a charge here, there would be a force pushing it in that direction. And we can draw a map showing all the different forces that there would be if there were a charge there. And since the plus charge is, since the force goes like 1 over r squared, there should be stronger arrows at the center. Because if there were a charge, it would be much more strongly affected if it were at the center. Okay, so this is an arrow map that shows the forces of this central plus charge if there were another charge nearby it at different points. So we're getting close to what we will call in the future an electric field map, but I won't try to explain an electric field yet. But the idea is that it's kind of like a map of an electric force, of the kind of electric force map that I've drawn. So now you know about 3 different kinds of arrow maps.